So properties and the uses for types of iron and steel. The first one, we have a cast iron. The cast iron is the iron which we extract from the blast furnace and we just mold into shape. That's called a cast iron. So cast iron relatively have higher percentage of carbon, so they are generally hard. And what are the uses? Because they are hard, so they are used for making engine blocks, like the engines. The main frame of the engine is made up of cast iron. Then wrought iron. If we remove all of the carbon, we call that as a wrought iron. And wrought iron, because there is no carbon present, so they are malleable. So as they are malleable, we can easily hammer. The term malleable means we can hammer them into shape. So it can be used to make doors or chains. So doors which are made up of iron or chains which are made up of iron, they are made up of wrought iron, means which does not contain carbon. Then we have a low carbon steel or a mild steel, also known as a mild steel. So low carbon steel, it's relatively so low carbon steel is relatively soft, and the car bodies are made up of low carbon steel, because the car bodies are designed to crumple as any accident happen. The reason is that why they're not using a high carbon steel, why low carbon, because low carbon steel, so it can deform. So if something which can deform during an impact, so less energy is transferred to the person, so it reduces the chance of getting a serious injury. Otherwise, if it was made up of high carbon steel, then the car will not deform and most of the energy will be transferred to the passenger and the driver inside the car. High carbon steel, strong and used for making the drills. Normally drills are made up of high carbon steel, strong and rigid, so it does not deform easily. That's why we use high carbon steel. And alloy steel or stainless steel, which is a mixture of nickel, chromium, and iron. It resists corrosion, does not rust. Corrosion reduces the strength of the metal. So stainless steel resists corrosion. That for that purpose, we use to make the chemical plants, as well as this cutlery, forks, spoons, knives are made up of stainless steel. So these are the types of iron and steel. You have to learn the property and why, what is the use for each of them. There are more, but I wrote one, that's enough. I will share the already shared the file with you related to this extraction of the metal. So there you can find more uses. What is the difference between high carbon steel and cast iron? The difference, a cast iron, it's having a variable percentage of carbon. Like variable, it is having more carbon, but we don't know what is the percentage. But in a high carbon steel, it's having a fixed percentage of the carbon, about 5% carbon is there. So in a cast iron, we don't know what is the percentage. Is it clear? Now some questions related to extraction of the iron. Question 8. What could be the answer for question 8? Iron from the blast furnace is treated with oxygen, which contain calcium oxide to make steel. Which substance in the iron are removed? So purpose of oxygen is to remove carbon, that's right. And purpose of calcium oxide is to remove acetic oxide. That's also right. So A is the correct answer. Question 16. The question is, what is not made? Look, we use for cutlery in a chemical factory pipes, but why the answer is given in the question they mentioned, but it costs much more than normal steel. For railway lines, because these railway lines are several kilometer long, so it will increase the cost of just putting a track for the rail or putting a railway track. That's why we don't use for railway lines. So C is the correct answer. Saucepans are made up of stainless steel. Pipes in a chemical factory are also made up of stainless steel. Why not railway lines? Because you can see the answer is given in the question. It is strong, does not rust, but it costs much more than the normal steel. So which is not made from stainless steel? The railway lines, because otherwise to put a railway tracks, it will cost too much if you are using a stainless steel. Is it clear? Question 16. Question 22. Look, impure iron from the blast furnace oxidized means addition of oxygen. Iron, impure iron from a blast furnace is converted into steel. Which statement about the process is correct? Acidic oxides are added to remove alkaline impurity. That's wrong. It is opposite. Basic oxides are added to remove acidic impurity. Coke is added as a reducing agent. Look, in this one, we already have molten iron. Coke is added as a reducing agent in a blast furnace, but this is not the blast furnace. This is a basic oxygen furnace. When we want to change the composition, this contain iron and some carbon. Oxygen is blown to oxidize impure. It's not add. Oxygen is not added to iron. It's not forming iron oxide. So that's wrong. Steel produced contain less carbon. Why it contain less carbon? Oxygen react with carbon, gives carbon dioxide, which will escape. So it contain less carbon. Question 26. Impure iron obtained from the blast furnace include carbon, some phosphorus and silicon are there. Which impurities are removed from a molten iron as a gas when it melted into steel? Yeah, carbon only, because carbon form carbon dioxide. Question 30. What's the answer for question 30? Which statement is not correct? D is the right answer, because when converting iron into steel, when you are converting iron into steel, you can see already it is impure iron. This iron is impure. What does it mean? It means it contains iron, some carbon, silicon or silicon oxide is there, and trace of phosphorus. So when you blow oxygen, carbon react with oxygen from carbon dioxide. When you add calcium oxide, or this oxygen can also react with some silicon, very trace or small amount of silicon is there, it will form silicon oxide. And this silicon oxide react with calcium oxide to form slag or calcium silicate. The question was, which statement is not correct? So which statement was, this is correct. Silicon converted into silicon oxide, and the basic oxide react with acidic impurity to form slag. The oxygen does not react with iron, it reacts with carbon to form carbon dioxide. Now the question from the blast furnace. The diagram shows a blast furnace. We are adding a raw material coke, iron ore, limestone, X and Y something is out. The following equations represent the reaction which take place in the blast furnace. Now the question is, which reaction is used to increase the temperature inside the blast furnace? Means which reaction is exothermic, release the energy. So carbon react with oxygen, produce carbon dioxide, so you will write A. Which reaction is an example of thermal decomposition? Thermal decomposition means one reactant and more product. So B is a example of thermal decomposition. Which reaction carbon in which reaction is both carbon oxidize and reduce? Oxidize and reduce means addition of oxygen and removal of oxygen. Like carbon is both oxidize and reduce. If you check this equation, carbon dioxide reacted with carbon gives carbon monoxide. So with respect to carbon dioxide, first it is carbon dioxide, then it becomes carbon monoxide. So whenever removal of oxygen we call reduction, and carbon become carbon monoxide, it means addition of oxygen. Addition of oxygen we call oxidation. So this reaction, carbon is oxidized and reduced as well. So D is the right answer. Which equation shows the removal of impurity from iron? Impurity from iron. So what is the impurity here? Look, iron ore and it contain impurity silicon oxide. So if we remove silicon oxide, so how silicon oxide is removed? By reacting with calcium oxide forming a slag. So C is the right answer. Because this is not an impurity in iron. Oxygen is not an impurity in iron. Oxygen is present in iron. It's a compound iron oxide. But we don't say like in this compound iron oxide, oxygen is an impurity. We don't say like this. If we have a mixture of two things, then we call one thing as impurity. So C is the right one. Which equation shows the reaction of acidic substance with basic substance? So metal oxide react with silicon oxide, acidic oxide. So C again, C is the right answer. Use the diagram of the blast furnace to help your answer these questions. What is enter at a blast furnace at X? What is enter at X? Hot air. The fifth one, which equation in the fifth one, which equation shows acidic substance reacting with basic substance? So metal oxide or basic oxide, and non-metal oxide is acidic oxide. So this is a reaction which involves acidic oxide with basic oxide. That's why C was the answer. What leaves the blast furnace at Y? Yeah, molten iron. You can mention pig iron or molten iron. Not only iron, it should be molten iron because it is at a very high temperature in a melted state. Name the two waste gases that leave the blast furnace. Which gases will escape from the blast furnace? Two gases. Carbon dioxide is one. Carbon monoxide, yes. So carbon dioxide is one. Oxygen generally reacted because it's an active component of air. Carbon monoxide is acceptable. Nitrogen, because air contains nitrogen as well. Carbon monoxide, carbon dioxide, or nitrogen you can mention. Not oxygen is reason why oxygen is not acceptable, because oxygen is an active component. So it react, mostly oxygen reacted with carbon to form carbon dioxide, and then carbon monoxide is formed because limited supply of oxygen is there. The graph shows how malleability of iron changes as a percentage of carbon in the iron change. Increasing a percentage, what happened to malleability? You just have to explain the graph, mention as a percentage of carbon increase, so the malleability is decreasing. Iron obtained in the blast furnace, contain high level of a carbon. How the amount of carbon in the iron can be decreased? So how we can reduce the amount of carbon? By pumping oxygen. That's right, by pumping oxygen, and what it will form? It will form carbon dioxide, which scrape from the molten iron. You oxidize it with pure oxygen in a basic oxygen furnace. 1 mark is for adding oxygen and 1 mark is for mentioning it form carbon dioxide. Iron is extracted from its ore using a coke in the blast furnace. Name the ore of iron which mainly iron 3 oxide. It's hematite. Yes, that's right. Then describe the reactions occur in the blast furnace. See a 6 mark for this whole question. 2 reasons why we use a coke, 2 chemical equations for reduction of iron, and explain the use of limestone. So why we use coke? First thing, so coke react with oxygen to produce heat. That's one thing. And coke help in or produces reducing agent such as carbon monoxide. Then the equation which involve extraction of iron, like iron oxide react with carbon monoxide, it form iron and plus carbon dioxide. Then what is the purpose of the limestone? The purpose of the limestone decompose to form calcium oxide, which help in removal of acidic oxides or acidic impurity. So using this, we will get describe a bonding in iron. That's related to metal chapter, like the structure of the metal part. So this was extraction of iron. Any doubt related to this extraction of iron? To remove impurity, silicon oxide forming a slag, there's a specific reason to use coke as they form a core. Look, the difference between the... So I'll end the session and share recording. Any doubt related to this extraction of iron in the blast furnace? Tomorrow we'll discuss how rusting of iron can be prevented and what is rust, and extraction of the other two metals such as zinc, extraction of zinc and extraction of lead. For extraction of zinc and lead, you don't have to learn the whole process. just Just the equations.